Hi, I'm Sean Gannon, and this is Minute Math. And we're going to calculate the area of this square. Now we have this figure here. We got a triangle, and I'm telling you there's a square on the inside. Not the best drawn square, but bear with me. You saw it was kind of a while. All right, we got a square, we got some side lengths, 3, 4, and 5. I want to see if you can find the area of that square. So take a moment here, pause the video, see if you can solve it. If not, we're gonna keep on moving forward. All right, so like I said, we have a square on the inside, so that means we got some right angles going on here, okay? If I can draw right angles. Oh man, that was not even close. Hey, we all make mistakes. Good thing we have erasers, right? Don't write in pen. All right, no, that's not even better. Anyway, we got a square. That also means the side lengths are all congruent. Great. What do we also know about our triangle? Hey, let's go label this triangle. Let's call it A, B, C. We got triangle A, B, C. What do we know about it? Okay. Well, let's say 3, 4, 5 triangle, meaning it's a right triangle. So 3, 4, 5. There's a special triangle here. Okay. We got a right triangle right there. All right, we got A, B, C, and D. I also labeled some more points. Let's go do that as well. Let's call it D. Let's call this D, E, doesn't really matter, but F and G. These little intersections going on right here, the corners of the square. All right, and then with that, let's go also label some more stuff. Why don't we say, hey, we know we want to find eventually the area of the square. Let's call the side length here of each one of those X. Okay, we got that right there. Now, what do we know about, we have a line, BA, and we have a perpendicular line that goes through it for the square. Square says it's a right angle, so that means the other side is also a right angle. Good to know. Let's go label some more points here so we get some information. I want to look at this angle right here. Right where A is, I'm going to call that angle alpha. So I'm going to say angle, let's call it DAG, is equal to my alpha, angle alpha. And I'll also say, well, right here, let's call this one, if that's alpha, let's call this one beta here. Angle EBF, let's call that beta. So angle, what do we got? Let's call it EBF is equal to my beta. Well, I'm going to try to take some knowledge that I have about similar triangles and see if other angles have the same exact value here. And this actually happens quite a lot. We have, if this is alpha, right, angle A, and that's 90 degrees, like we had before in the big one, right, then we can say that this angle right here that I'm pointing at is beta, right? Complementary, it has to add to 90 degrees. So angle DGA is also, DGA is also equal to beta. And similarly, we can do the same thing down here. We have the angle beta, we have 90 degrees, so angle EFB is also equal to alpha, okay? And what does that tell us here? Well, since these triangles, right, triangle DAG, BEF, and our larger one ABC, all have the same angles, the angle theorem would say they're all similar. So I could say triangle, let's keep it all the same. ABC is similar to triangle. Keep alpha would be F, so triangle F. Then we go to the other leg. BE is similar to triangle. The big, this one, AGD. AGD. So we have 3 triangles that are all similar. And you can guess where this is going. Their side lengths are proportionate, okay? Now, we said our big triangle is a 3, 4, 5 triangle. So how does that 3, 4, 5 triangle help us? Well, let's go look at triangle ADG. Triangle ADG. I'm gonna redraw this here. ADG here. And I'm gonna put it as A, D, and G here. And this is a 3, 4, 5 triangle. We know it's similar to ABC. So let's go in terms of x, let's go write that down. It'll be any times x value, 3x, 4x by 5x. Hypotenuse is that AG, so that's gonna be similarly the 5x, let's call it. And the 3 would be the AD, then 3, so 3x. And then GD would be our 4x right there. So if we set all this up, what we can do here, I want to get that x right here, that DG is equal to x. I'm going to rewrite this GD to be equal to x instead of 4x. So to do that, I have to divide 4 to all other parts. So that means my triangle here, we have G, D, and A, again, can be, we'll divide each part by 4. We have 5x over 4, 3x over 4, and the 4x over 4 is just our x value. And now we can write these side lengths in terms of x, because we said that was equal to x right here. So AG would be 5x over 4, and AD, 3x over 4. Now I'm going to do the same thing with this triangle down here. All right, the second one. What we have is we have triangle, keep it all congruent. I put my alpha angle up top, so like this, boom, 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 okay? And that's triangle F up here, F, and then it goes to E and B. We know it has, again, a 3, 4, 5 type triangle because it's a similar triangle to our large one. So we have 3x, 4x, and a 5x here. But in this case, what I'm going to try to do is see if I can get EF by itself. And to do that, I'm going to divide by 3 to all parts, and I have x really by itself there. So rewriting this out, if I divide all parts by 3, I have an F, E, and B here. Divide all parts by 3, we have, well, x, 3x divided by 3 is an x. We have 4x over 3, and a 5x over 3. So we can fill those values in. X is already here. BE is that 4x over 3, and BF is that 5x over 3. So now we gotta kind of combine everything together. What do we know about the length of BA, AB? It's 5. It's also written in terms of x, and now this is an algebra problem. We know that 4x over 3, that length here from BE, plus x, e to d, plus d to a, which is 3x over 4, is equal to 5. And we can solve for x right there. So what I'm going to do is I'm going to multiply, well, 3 and 4 common denominator is 12, and multiply basically everything by 12 here. 12 to both sides. Let's do some math here. 3 goes in 12, 4 times 4 is 4, 16x, plus 12x. 4 times 12, 3 times x is 9, so we have plus a 9x, equals 5 times 12 is 60, okay? Combining that like terms, let's kind of jump over here. I think there's some more room here. 16x plus a 12x plus a 9x gives me a, what is that, a 37x. So we have 37x is equal to 60, okay? From there, so we divide both sides by 37, and x equals 60 over 37. And so our side length of our square, which we found, is 60 over 37. But the question's asking us for the area. So the area of our square is side length squared. So it's 60 over 37 all squared, which comes out to be a good old number, 3,600. Over 37 squared, which is 1369, or approximately, as a decimal, 2.6297, and that's gonna be units squared. So either one of these works for me, but there we have it. We found the area of our square, which was 2.6297 units squared. Was that the answer that you got? If it was, way to go. If it wasn't, hopefully this video was informative and you learned something on how to, well, solve these types of problems. And I hope you liked this video, and if you did, make sure you like the video and subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So, as always here, thanks for watching.